Hi everyone, myself Arun Kumar from SNS College of Technology in the Department of EC. In this video, I'm going to share about polar plot in frequency response analysis. Understanding the users and system needs, it is comes under empathy part. Normally, the user need to know about the frequency response characteristics. It is purely based on magnitude and phase of the corresponding system. And let me see how these magnitude and phase of the angle has been assigned for the particular system by using this body plot. And frequency response challenges. The challenges here is to measuring the system by using magnitude and phase angles. And the critical point of the system design is based on the components like filters, amplifiers, and complex control systems in various engineering disciplines. Because these are all the key factors to decide the particular frequency of the system, so that the frequency has been moved towards the destination without any delays. Next one is ideal part. It is based on exploring the strategies and metrics. It is to be followed by the mathematical calculations part, because even though we know about the particular frequency based on the signals, in order to achieve this signal, we need to measure the particular frequency has been done by using the mathematical formula. So it shows that the frequency response characteristics based on the roots of the signal, for example x square, x cube, like that the system has been generated with the help of the mathematical calculation part. So here they are using omega is frequency response characteristics for getting the informations from the system response characteristics. And based on this we can able to configure and mapping the input units. And next one is complex planet. So the complex planet is, even though we are having the points in positive waves, sometime the values we may get in complex mode, so that we can able to verify the signals in the respective negative part also. So it is very useful to find by using the magnitude part, so that we can able to catch the particular point of the signal very clearly. And next one is visualization. After getting the waveform, we need to check whether the system to be represent as what we have expected. That the dynamic curve has the polar plot, which is a graphical representation of the omega, so that the plan has been generated based on the input signals. And next one is tracing the system responses. In order to achieve all those positive negative comments in the system, we need to find the responses of the corresponding frequency, so that we know about how the signal has been passed from the input signals. And next one is combined gain and phase. So the main purpose of this generation of system response is to getting the gain of the particular product. And while getting the gain of the product, we need to check the corresponding phase signal to be transferred from starting position to ending positions. Next one is polar plot second order system. So the main function of taking the second order system is we have order as 2, so that particularly the frequency response to be maintained within the region of the circle, so that we can able to check which type of an angle is to be fetched in this polar plot, so that the particular angle has been measured, and it can be identified by with the help of gain of the systems. Applications. There are a lot of applications are there for using this polar plot. Especially we are using here three type of applications. First one is stability. I find out stability is the common factor for checking the frequency of the system. So we can use to this model as a stability finding process. And next one is resonance diagnosis. The resonance is nothing but how the data has been processed from source to destination with the help of input signals. So it is known as bandwidth, so that we can able to calculate the bandwidth also. And next one is filter design. The filtering is purely based on input signals as well as the use representation of phase shifts and corresponding the angles of the systems. Activity here, the activity given as think pair share activity. The topic is polar plot analysis in frequency responses of control systems. The task which is given as polar plot represent the system frequency response in the complex plane and helps in evaluating the stability and system performance. So take a 5 minutes and then discuss with the partner. Then the role is the polar plot is a stability analysis and control design. You need to be considered for this topic as a group. I mean, thinking paired activities assessment. Gain margin in polar plot is determined at the point. The here answer is phase is minus 180 degree, because the 180 degree is shows that both positive and negative values to be around the frequency of the systems. And next one is a system is considered stable if the polar plot is, the answer is does not encircle the -1 and j0, because whenever we get the poles and zeros, this is the common factor, so that we need to consider this does not encircle point for making the equation as open loop stable systems. And mind mapping, so the mind mapping is nothing but what the things which will define exactly. So here we can able to get the data exactly based on the frequency response characteristics. So these are all the references I have taken for my video. Thank you.